So good morning or good afternoon, depending on where you are based at. Um, Welcome to this webinar. We are going to present you two different things today. One is related to the new update on our software for the GS8000, and the other is related to the post-processing software GPR Insights. So I have with me Alex Novo, who's going to present you the second part of the presentation. So Alex is here. Alex, you can say hi.
Hi everyone. Yeah, looking forward to this.
And
Thank you, Michael.
I'm gonna present you the first one, the first part that's related to the software update. So this presentation is made along with Gorka Santamaria, who's the product manager for Geomatics. And my name is Michael Arvanitis. I'm actually the head of GPR product and strategy for Screen and Eagle Technologies. Just a few words before we start about the company. So Screen and Eagle Technologies provides a technology platform for inspection of the built environment. The company was created through the merger of DreamLab with Singapore and Proceq in Switzerland, with a mission to protect the built world with software, sensors, and data. So the first part of the presentation is actually comprised from these segments. So we are going to make a short introduction. We are going to discuss about the application itself, the ecosystem, a short technical overview, and then a bit about, an annex or a summary of what we have already said. We have tried to make this presentation as multitasking as possible. That means that you will not see too many words in the slides. So we try to include many videos in order to make you understand how it looks, how it feels to collect data with the new app. So if you're ready, we can start. And this is a very important slide because that describes what's happening right now. So let's say that you are a utility locator or someone who looks for utilities for his living. So today, if you want to collect 3D data, or if you want to make absolutely sure that you haven't missed any utilities or pipes, you have to follow a specific collection workflow. And this is comprised by preparing. That means you need to set up the grid, so that takes time. You need to scan through the grid that you have already drawn. That means that you have to collect lines in horizontal and vertical direction. And that adds to uncertainty because most of the times we set up the grids without really knowing what's beneath. So we set up the data collection pretty blindly. And then you have to collect marks with GPS. If you don't have any synchronization between your GPR and GPS, that takes time. Time means money for you on the field. And then the last part is you have to make a report. That means that you have to go to the office, post-process the data, which takes time, which takes also someone who's an expert on post-processing of GPR data, and this adds to the hassle. So this is the current workflow. What we suggest is something very different. So we are proposing a new data collection workflow. So it's not really an update. It's not just an update. It's actually a new data collection workflow. So with the new version of the GS, we suggest that you take a shortcut through your, let's say, everyday work life. So right now, you don't really need to prepare any grids. So you get freedom. You are free from grids. You don't have to spend time in order to take some lines, draw lines, make markings on the road, whatever. This is a thing of the past. And then we suggest that you just go over there and start scanning. So it's real-time 2D and 3D scanning, and this is being displayed directly on your screen. We also say that you don't need to go to the office after that. So what we suggest is that you have everything on the field. So you can collect data, you can see everything on the map, and then you can report that or export it, send to a customer or to a partner with just a click. So from the field to the client without really, one, drawing a grid, and two, actually going to the office to post-process or prepare the report. So in a nutshell, we are saying that the new version of the GS8000 is not just a ground penetrating radar system. We call it the subsurface mapping system because that's what it does. It puts things on the map. It puts the subsurface information on the map directly for you. Let's say a bit about the app, the application itself. A few days ago, we have released our video where you have seen a glimpse of what's happening with the new software update. So you may remember that people were just collecting data without any hassle, and you could see things appear on the screen in 2D or 3D. So we are going to discuss a bit about that. So the app update that we have just released goes beyond the new data collection method. So in the past, previous users of GS8000 may remember that you could use either a line scan or an area scan. That means that you could collect just a line of GPR data over here, or you could draw a grid and collect 3D data through an area scan. Now we add something new. We add the free path. So with the free path, you actually get the best of these two worlds, the line scan and the area scan, without the hassle. So what it means for you? More freedom, more efficiency, lower costs, and so on. So let's discuss about that. With a new GS version number 2, you save time because your workflow is more efficient, is faster as well. And on top of that, you get intuitive data. You can still get the 2D hyperbolas that some of you are maybe used to that, but you get something more. If you see over here, you can get some data from 3D, more or less, on a map directly. And of course, the new update adds value because you don't really need to go to the office and post-process all that, and you can start to deliver almost directly. So with the new app, you just turn on your GS8000 and you start scanning out of the box. No grids, no spend time on the field, and you can start collecting data, even in confined spaces. Because a big problem with the grids is what happens when I don't really have the space to make a real grid. I have to make something like a grid. So the new version actually gives you a sort of tomography in real time. So if you see the screen over here, you can see that the screen is split into different parts. One has the 2D classic GPR data type like display over here, and the other has the map where you can see how these things appear into the 3D version. So you don't have anymore the uncertainty of the GPR data. You don't have to wonder whether this hyperbola is actually a target or a multiple reflection or even a false reflection from something different than a pipe. And that means that your interpretation is more accurate and easier. So we have created a video just to show you how things work. So I will play the video and I will explain you exactly how these things work. So this is the screen that you get from the application. So when you download the new application, you can see the screen and you can start collecting data. Let's see how this works. So you can see over here that you can load maps to your tablet directly. So if I have to go to a specific area, I can load either satellite maps or Apple Maps and put it on and have it on my tablet. And then when I go to this place, the map appears, and this small square over here is actually where I am. And what happens over here, we took this example because we would like to show you that even below the trees, the GNSS reception is very good. So you can still get data, you can still get accurate positioning of your equipment. So what happens is you load the map, your tablet, and you are ready to go. Over here, you can see the things about the GPS. We are going to explain this in details in the next slides. So you can actually select the coordinate system, the position type, and so on. And when you're done, more or less, with the data parameters, you can start collecting. And you can see over here something really amazing. You can see that on the left side of the screen, you get still the classical GPR picture of hyperbolas and so on. But here, you get the line, and you can see the targets as they are forming in 3D, which is pretty impressive. So if I continue collecting, I can split my screen on the right side, and then I can draw targets, or I can annotate targets easily without stopping the collection of the data. I can zigzag with my scanner, and the GNSS is actually correcting the position, so you don't really miss any data. Everything is put in line. So you can see over here that the targets are being formed as I'm moving my GPR randomly. You see, I'm just zigzagging over there without really taking care of my position. I don't care, I just take lines in random back and forth, and then the whole thing is appearing directly on my map. So it's not anymore another set of hyperbolas. It's actually a set of maps that's being displayed on my screen. So if I fast forward a bit this one, you can see that there are targets that are being formed over here. And this appears like that after a few lines in just a matter of minutes. So that's very important. If you compare this with a typical grid data collection system, that would take probably an hour to collect, because you need also to do the grid. So what I do over here is I change my depth size so I can see my targets at a different depth level. I can annotate targets over here. These targets appear as well on the map, as well on the radar gun itself. So pretty flexible, many terms, and pretty fast. So what happens, what we realize is that now you can actually digitize and sketch directly on the map. So you don't need extras. That means that you don't need to invest in time and money for the process of mapping, and you don't need to do any conversions. So all findings or subsurface information is being digitized in the same map and coordinates. So you don't have to export, for example, in Google Earth or whatever, or any other GIS. You can still do it, but you get all the information on your screen. So I don't know if it's necessary anymore. And you can get all the other information like annotations or whatever you may have over there. You can still get it on your map, digitized directly to your customer or to your office. So the mapping deliverables, as you can see, it's only a click distance from the spot, from the site that you are working. We add value to your work because we are compatible with most common CAD or GIS deliverables. So in case you want to export the data, and you still need almost zero office time to get the report and send it to the customers. So you can see over here from the tablet, you can end up either to our platform that's called Workspace, or you can share it to any other GIS or CAD systems that you may work with and you still want to work with. So the data collection, the app is rather simple, as you may have seen. We have played the video before. This adds a bit more information about how the data collection is working. So we take it from the last part. So you can see over here, what I do is I play back my data. I go back and forth without really collecting data. I change my depth size over here, my depth thickness, and I can see or actually hide different targets. When I do that, when I play with the depth size, I can still see the annotations, which is pretty important, okay? I can do a few things like removing the grid lines from my map if I don't want them to appear. So if I think that the zigzag lines are not really useful, I can actually remove them. And over here, I can draw the pipes or the lines or the utilities with this simple tool of annotating. So I place that and I can see the line here, okay? So I make it as simple as I can for my customer. Same here. I put the annotation, I draw a line, so the customer can see a line and not anymore a hyperbola or something that looks like a difference in colors. And many people do not understand if they are not experts. So we make it as more, let's say, we try to express it in the most simple way as we can, okay? Playing with the thickness size and so on. And then you can export this data or generate a file, send it to your partners, send it to your customers directly through Slack, through emails, through whatever you may like, okay? So very, very simple procedure. Now let's try to describe the ecosystem, because the update by itself is fine, but what happens with the whole ecosystem? How this is being supported by the other things that we are providing to you, to your customer. So right now, the ecosystem can be displayed like that. So you have the GS8000 on the field that collects the data. That's the hardware. It has also some brains with the iPad. And then what you can do is either send this data to your workspace account, or if you want, you can share it directly to your customer by skipping the step over here. Or if you want, you can actually be in workspace and then use the GPR Insights, which is an advanced post-processing software package that Alex is going to talk about later on. For those who don't know, Workspace is a free service provided by Screen Nickel Technologies. It's a platform. It's an operating system agnostic platform, actually. That means that you can run it from any device that you may have, and people can actually share data in there. They can see data, they can see a preview of the data, they can see the notes taken from the field and so on, and then create a sort of reports from there into the customers. So for example, if you don't trust the guy who collects the data, you can ask him to send the data to the workspace account. Then someone who's more experienced can take a look and then send to the customer. Although we are trying to skip that step because of the easiness to collect data and see things on the screen, some customers may still need it for verification procedures and so on, okay? The other layer we are adding, and that Alex is going to talk about, is the GPR Insights, which is very important for most advanced users, okay? So the workspace, just to conclude, you can make reports, you can have sketches, you can export to Google Earth or to CADs and GIS. Very, very simple. So that's more or less the ecosystem. Now let's discuss about the application itself, how it works. So we are saying that it's very simple, but is it really that simple? I would say yes. Based on my experience with GPR for the last 20 years plus, I would say that probably this is one of the easiest, not the easiest, application that I have worked with. So what you get is this type of screen on your iPad. So you can see the radargram on the left side and the map on the center side, and then you have this tab over here where you can control a number of functions. So you get all the information in one place. So if you have an experienced user, he can still get some information from the radargram. If you don't have someone who's experienced, then he can see everything on the map directly. So this is more natural to people. I mean, most people, even my kids, will understand that. This is more for the technical guys that they know what they're seeing over there. This is for the experienced user, okay? So we try to combine the best of both worlds. Now, how easy is to navigate to that? I would say quite easy. With touchscreen controls, you can do almost everything you need. So if you use your 2 fingers, you can switch from the map version of the display to a migrated view, just in case you are an experienced user, or you can just have the radargram view if you are a radar guide. So it's up to you to decide what you want to keep or not. We believe that the mapping tomography section over here in the center is very attractive to users. So most of the users are going to use that. So with your two fingers, you can zoom in and zoom out very easy, very naturally. So if you do that, expanding, you actually zoom in. If you narrow that, you actually zoom out. Okay, so you can see the stuff. With one finger, you can move into the screen, so you can see different things. And let's discuss about what you are seeing here on the screen when you turn it on. So you can see the box of the local coordinates provided by the GNSS on real time. Okay, so you can see the bottom left side over here, and you can see the top right side of the coordinates over here. So very typical, very classical way of showing the coordinates in a GIS or a map system. Over here, you have the current scale. So that means that this is 5.6 meters, for example. And with this one, you can actually zoom to the full extent, the map over here. From here, you can load the maps or satellite images, whatever you like the most. And this is where you can see information about the current GNSS position quality. Okay. Now, this about the map. Let's talk a bit about the other stuff as well. So, if you have some experience with the GS already, you may remember this green button. Okay. So this is the start button. Okay. By pressing that, you can start the data collection. So I made a video for you, and this is by pressing the button over here. You can see I can start collecting data. So the thing is that by pressing the button and moving your unit, you can start scanning. You can change the depth range. You can annotate on real time without stopping the data collection if you want. You can change the gain. You can increase or decrease the gain. Very simple, without really doing anything to stop the data collection. You can roll back and add marks, and you can tag on the radar graph. That's without stopping the data collection. You can still do all that without changing or stopping the unit. So you can see over here how these things are being formed and so on. And I can see a nice pipe forming over here, the red one. Okay, I can see my zigzag lines, which actually annotate the way that I'm moving. Okay, you see a very nice pipe it's forming over here. Now, if I don't like the gain of this data, I can change it without a problem. Okay, if I want to put any annotations, I can do it. For example, over here, I annotate that and so on. Very simple, very easy. Let's see what happens when you pause the data collection, okay? So you see this button over here with the two parallel lines, and this means that you can pause the data collection. So what happens is that your scanning gets interrupted. That means that you don't collect any data anymore, and you can review your base scans, for example, or you can move your unit. For example, if you are collecting data and you find an obstacle somewhere in between, you can move your unit without really collecting data. So you need to pause that. And then the unit will actually resume from the point that you moved to the GPR unit currently. So let me show you a bit how this will look like. So I'm collecting data, okay? And I pause it over here, okay? Now I still collect data over here. And I can press that and pause my data collection. Very easy. And then I can move my unit. For example, if I have this car, I need to move it somewhere here to start collecting data again, and so on. Okay, now, this button over here, it's something that you may remember. It's actually the start collection or the continue collection of data. So you can now move and place points of interest. So if you see the video over here, I can annotate, okay? Over here, I can change the depth size from here. You can see I'm now moving. I'm going to another place without collecting data because I have paused my data collection. And when I'm ready, I can do that, okay? For example, over here to annotate. and start my data collection again. So if I press continue a second time, my scanning gets interrupted again, and the position of the GS 8000 moves as you move it. So this is something we have already seen. Okay, this is, I'm moving my GS and now I collect that. Okay, very nice data, which can be actually interpolated with the data that I have collected over here. Okay. Now, what happens after I have actually collected some data? So right now I'm just reviewing my data and say, okay, great. I can see my data right now. I can see my Bscan over here on the left side, and I can see my map over here. So whatever I do on the display range, for example, on the thickness over here, it has an effect on the map. So if I change my display range over here, then I can see that the map is changing over here as well, which is really important because I can choose a very specific depth range, and I can say, for example, I would like to look into a depth of 0.5 meters down to 1 meter. That's all the information I would like to get. So I will draw a map only at that depth level, which is sometimes very necessary, very useful when you're collecting utility data. So when you do that, over here on the Bscan, you see the effect on the map side of your screen, okay? Whatever you do, either the depth size or the gain, for example, or any annotation you do, okay? So if I change, for example, the resolution, so if I change to move my frequency, what happens over here is that I have my raw data, my Bscan, okay? And then I move my two fingers over there just to see the high frequency range of the antenna, okay? So even if I do that on my Bscan, I can still get the updated version of the map over here. So I change the active depth range from low resolution to a high resolution that is being displayed on the map as well. So the tomography updates in real time to combine both images. Very important. The same with gain. If I adjust my gain on my radiogram, I can see the gain being adjusted on the map as well. Okay, very easy. Now, the same with the annotations, the same with the section length, the same with zoom ins and zoom out. Whatever I do on the Bscan is actually displayed on the map scan, okay? Placing markers, same stuff. So if I place marker over here on my Bscan, it's actually being displayed automatically on the map. Really, really important if I want to locate pipes. So many people are using locators right now to get a picture of what's happening on the subsurface before going with the GPR. Right now, you may trace the pipe by just zigzagging on an area and see how the pipe is moving, how it's being directed into the three-dimensional reality that you are working on. So very, very important. You can annotate, you can actually put annotations, and then you can see everything on the map. And that's really, really helpful because you can draw this line no matter how it moves, okay? Trace a manual utility line or time size view. It's what we have already explained. So you can annotate over here, and then you can see it on the map over here, the other side of the map. The coordinate systems, and that's pretty important, and we are probably the only company that offers that, is that you can set a UTM time zone or a local coordinate system from a list. So you don't really have to convert anything into a different system. Let me show you how it works. So on the main screen of your application, just before you start collecting data, you can go to the positioning, you can go to the coordinate system, and you can actually select what you would like to work with. So you go over here that says UTM, okay? And you can select the country specific, really nice, okay? So if you work in a specific country, you can select that area. And based on the country, you can select which specific system you would like to work from this country. Very, very important. And then you can work on the local coordinate system, which is very useful most of the time, because what's the meaning of going to a place where they use a different position system and try to position everything on a map that has my own position system, which is different than the local one? Someone has to convert it. Someone has to spend time on a computer trying to convert that into a local one. So that's the easiness of the new version of the application. We provide you the tools to go there, to go anywhere, and work directly on the local coordinate map. Very, very useful. So let's see a bit about a few more videos about how this works. So you can see a sort of a map over here with a bit of a gap, but still even the gap that exists over here, I can change my depth size and I can see how more or less the pipe is being formed. I can annotate that, so I can draw the line, okay? And I can even draw something on the map directly without really having to say anything. So I can keep a note of that and say, look, you need to be careful on this point or whatever, okay? It's just plain flexibility. So you have a map, you can do whatever you like on the map. You get the information from the ground penetrating radar, and then it's up to you to decide what to do with this map or this information. Another video, just to show you a bit of the flexibility. So you see how easy you can draw a line. You annotate that, and boom, it's here. So let's see a bit about the image processing and how this actually affects the display settings. So I can play with my parameters over here, and whatever I do with the gain actually is being displayed automatically over here. What I'm doing on the left side is changing the depth size, okay? I can see different targets at different depths, okay? Now I can collect data. You see my GS is moving. I'm collecting data. I'm moving to a random direction. I'm getting back. Still on collection mode, trying to see how this pipe is actually forming, this pipe, how this pipe is forming. If I'm not happy with any of my display settings, I can play with the gain. So I can increase or decrease the gain, either linear gain or time gain. I can change my scan width from here, so I can make it wider or narrower, depending on the resolution that I would like to give to my data. I can smooth out my data. I can remove my grid lines just to have the targets. I can zoom in. And of course, I can add targets. If there is something that I cannot really find over here, then I can create my own annotation. How? Very easy. I just add a user selected annotation, give a name, give a color, and that's it. Okay, I can have my own targets in there. See how easy it is to annotate. That's the new one. That's something that I don't know, so I call it unknown target. And this is it over here on the map. Okay, directly. No synchronization, no post-processing, no nothing. Now, before we actually conclude to that, I would like to tell you a bit about a new function that we have. It's not really related to the the GS version number 2, but it gives you more flexibility to work with data that are coming from difficult soil conditions. So we have a new noise interference filter. It's actually a filter that reduces the noise or increases the signal to noise ratio that you have in the radar. And it's very simple to work. So this is some data that we have collected over a very bad for GPR soil. And with this filter, with just a simple click over here, the noise cancellation, you can get data like that. So we remove quite a lot of the noise from there. So that's more or less from my part. So I will stop sharing my screen right now, and I will pass the floor to Alex to talk to you about the GPR insights. After he's done, whatever questions you may have, you can write them on the chat, and we can discuss about the questions that you may have at the end of this webinar. Okay, so Alex, it's up to you now.
Thank you, Michael. Very interesting presentation. And yeah, now I'm going to talk about our new software for data analysis or post-processing. Based on what Michael presented us, you might think, right, you might wonder why we need a data processing software. So I'll try to explain that in certain situations you might need it, and also there are some people, we hope less and less with time, that don't have the GS8000 yet, so they cannot access to this workflow that Michael just presented. So I'm going to do a brief introduction, then a product overview, also following similar pattern as Michael's presentation, talk about how this fits on our ecosystem, and then go a little bit more in detail on some features or on a technical overview of GPR Insights. And I will conclude with that, and so we have time then for questions and answers. And yeah, I prepared this with Michael supporting, and my role at the Screening Yield Technologies is Head of Product Management for GPR applications. So I'll start with this. No, it's not the most beautiful picture, unfortunately, but you know, we have some bad news coming from South Florida and Miami, a place that actually lived for a few months many years ago. But you know, this can happen everywhere. And in these Champlain towers, there was problem with integrity. But what it is important here also is like the amount of money that is lost on what it was called bad data on this report. And this is a pretty recent report. And just let me read some of the phrases, sentences that were interesting to me. So this was a survey focused on the effects of bad data. Defined as inaccurate, inappropriate, incomplete, inconsistent, and untimely. So just let me go to this. They say that the power of good data. No, the study found that the intentional data strategies supported more consistent data-driven decision making. That is what we are doing, improving workflows, if you think about it. And then how you do a regular review of your data for quality. Well, data analysis platform could be one way to go. So structuring data in a common data environment for centralized access could help. So if you remember that slide with the whole ecosystem is showing pretty much that. You have workspace as a central point where our data goes from the field and then can go to a data analysis software to check for this bad data and then go back to the centralized access that is workspace in our case. So immense value in putting together some frameworks for data acquisition, data analysis to evaluate this potential loss that here. This is a worldwide estimation of $1.8 trillion. So data analysis is key for efficient data-driven decision making. Another reason why data analysis is important, so sometimes you need to do an extra effort on data post-processing. This is data provided by Guido Tronca. And this shows a lot of B scans, a lot of radar lines collected over this arch on this bridge, and he adapted all this data to the geometry. And why? Because here geometry is key for data analysis of complex structures like this one. So this is another reason why you might need to do some data analysis on this extra effort that we'll see how much of an effort is, or it used to be, and how much is now with insights. Another example is when you try to, and this somehow we can do also on the app, as we showed, but as projects get larger and larger, you might feel sometimes more comfortable of bringing context to large projects at the office or in a different platform than not only on the iPad. We allow for that with GPR Insights, and this is just an example showing that rich context is key for data interpretation. So it's not only about GPR data, but all the satellite imagery, as builds, and field interpretation that then you can review after the fact. Another example is like very, very large areas or remote and topographically abrupted, difficult to do certain things. In this case, this is archaeology, of course, early Bronze Age site in the Euphrates Valley, 4 hectares to map. This is difficult to do with grids. It took a lot of time. I was involved on this project. I wish I would have the GS2 with the GNSS, but still, then this would require probably a little bit more extra effort for data interpretation, since with archaeology sometimes it's more involved to find the targets, and then sometimes to produce this sort of deliverables. And all this helps a lot. This digital preservation is really important worldwide. This site that I show, who knows if it's still possible to work there and do excavation. And also excavation of large areas is very expensive. It's not sustainable. But digital preservation sustains culture. So we promote that with data analysis. So what is preventing nowadays this to be common or more common? Well, we find in the market silo solutions. I'm not putting here any logo, but most of the GPR data analysis software, not all of them, but most of them, they are locked to one manufacturer, or one single file or two files, two file types, the ones that this particular manufacturer provides. Another problem is that most of the data is still being handled manually, which that creates a risk in losing the data. So people tend to also finish as much as possible in the field, which when you can is fantastic, of course. Nothing against that, as we show you. If you have the proper system and the proper software and you have good raw data, then of course it's possible in many occasions. And the other limitation, this is a huge bottleneck, is complex workflows on data analysis software. And there are many companies that they have several crews, but there is only one person on the company that can do advanced data analysis, and that is a huge bottleneck in order to provide rich deliverables, and that you depend only on that one person. That means that you are not going to provide those deliverables very often because of the workload for that single person to deal with. So I'll show you now in the product overview how we are tackling these limitations. So Screening Eagle GPR Insights is a web-based software with an intuitive workflow for advanced GPR data visualization and analysis. That would be the definition in one sentence of our new product. And we put a lot of emphasis on this sentence here: visualization is at core. So most of the times when you open a post-processing software, you have to go to a menu, follow several steps, open a file, load the data, create some sort of positional information, then run some navigation on the information, some parameters for filtering, slicing, gridding those data sets, and creating finally this sort of view or a three-dimensional view of the raw data. Well, we are putting this emphasis that from the very beginning you have visualization of the data at core. Then of course you can do all that I said and edit the data, but you start by visualizing your data from the very beginning. So you have here an example of how the main stage looks like. I will go more in detail, but this would be the C scan, a migrated B scan. You can see also more raw data migrated and A scan also, everything on the main stage. And you can switch here and convert the 3D window into a two window, or one window, or even 4 windows. And also you can add layers of information like in this satellite image here. So this is how the standard workflow, or one of the standard workflow, possible standard workflows would look like nowadays, going from raw data to 3D. And this is, for getting to here, to what I have on this slide, then you will need to go through these 50 about steps. And of course, that can be a daunting task. And to me, the analogy, while I was thinking about, and don't get me wrong, I did this many times during many years. I was involved on these kind of workflows a lot. But the analogy would be, and I don't practice this myself, but I have friends, and I did once or twice, but it would be like a solo climbing. So it's a lot of effort. It's nice when you get up there, but it's a struggle during the way, unless you are a very passionate, of course, climber. And but you need to be good, and you can fall at any time on this workflow. And you have to start from scratch if you fall, if you're lucky, survive. So we are providing a more intuitive workflow. We created automation on this, on many of these steps. So it could be for us, and I'll show that on a video, you would import your survey, your measurement, your data set. You would create a project within Insights, and then you would go directly into 3D visualization. I'll show you this in a video, how this in real time looks like. Some of the characteristics, and you probably heard about it because we show on the keynote on September 29th, we have a good partnership with GPR Slice, and this provides quality with GPR Insights, where we have access to this most renowned data imaging software and its algorithms for data analysis and imaging. So you immediately would benefit from reliable and repeatable results. This intelligent automated workflow allows you to increase productivity. So there is no steep learning curve, and you get to your results faster than you used to. And also we are, as Michael showed on the GS, we have a wide range of export and import formats. Then this is an important one, is fully web-based. That means that it's platform independent, so you can access your data from your preferred device, from any operating system, any computer. Doesn't matter the power of the computer. So you can have the same performance from a cheap computer than from a high-end computer, and you can use any web browser. Also very important, it's a universal software. That means that it's device agnostic, meaning that import data from any GPR. I'll go more in detail on that later. And you, as a user, you would have access to our ecosystem, even if you are a third-party GPR user. So you would have access to Workspace. And you can also import data from other type of data, like as builds, as DXF, or other type like data interpretation. And yeah, as I was saying, here this is another example of the Avanche amphitheater. It's very intuitive workflow because we keep visualization at core. So you're gonna be seeing at all times the effects of what you do, and you depart from data. You not depart from just an abstract menu or just steps to follow. So you have access to full visualization from the first click. And as I said before, you can manage the amount of windows from 1 to 4 that you want to visualize here, different B scans, migrated, unmigrated, the C scans, the 3D. And as well, you have on the main stage also all the access to positioning, to filters, slicing and gridding, 3D volume. You can import field interpretation, as I said. Then this also quite interesting. You can share your data via URL. So collaboration options, and you will get instant notifications within our ecosystem. I'll show you where that is in a second here, where I'll show you the main stage within Workspace. This is it. So when I was mentioning these notifications, you have here the notification bell. So you will have information about new releases or anything here. This would be the main point of entrance. So you would click on, actually, let me show you in the video, because this is an example where I'm gonna load some of our data. And actually this is a data set of the GS8000 free path. And actually was one of the data sets that was on Michael's presentation when he started talking about the synchronization of the different views. I'm going to choose the high frequency set of data here, just giving it a name. Now it's going to take a few seconds to upload. This is, I think, more than 2.5 kilometers of free pad, if I'm not mistaken. For some reason, I cannot see the video because I think this should have been over by this time. I don't see the, let me see. Oh, yeah, I think it was paused. So you can see here the amount of, so it takes like less than a minute. This is in a staging environment. Of course, when we release, this is gonna be much faster, but just to give you an idea, what it's doing now is doing all the filtering, all the processing automatically. So we have a battery of filters that, of course, you can configure. We have one by default to give you in few seconds here the full data set in 3D. So here it is. Now I'm gonna switch off the lines and the line names. And probably you remember this is an intersection that actually shows quite a good amount of pipes running in different directions, even diagonally on this intersection. I'm gonna place satellite imagery on the background. There you go here, and here you can, switch and look at. Now I'm gonna look at data with probably I would increase a little bit the gain here, but just to show you on a quick video, the 3 views here, a nice hyperbola, then just Hilbert transformer here. I can scroll the C-scan, and one nice feature that I like, you can see on this yellow horizontal band, that's the level of the depth slice, and as Michael was mentioning also, you can control here the thickness. So it's pretty useful here to have it on the Bscan. Okay, now let me show you quickly how you import data from third party. So here we'll go to new project, other data, and then if you receive, for instance, here any error, then you have a list with some brief instructions to give you what to put, but basically you just need to zip all your files and put it there. Then it's importing this dataset, and we'll show here in a second. This is a smaller dataset, much faster to load. And here is computing a 3D volume, so it's quite fast. And again, it's not going to depend on your computer. So you can go to an internet cafe and access your data. You just need your credentials and go to workspace. Here it increased the radius and created another volume immediately. And here, another example, but this time we imagine that you don't have, sometimes you collect data or you use data that somebody collected time ago or from an old system. There is no GPS, there is nothing. You just have a bunch of lines. Here I have 160 something lines. Actually, this is quite an old data set, and I was involved on this data collection. So the only thing I knew was the spacing. It was 0.5 meter, pretty common for archaeology. So I put everything together. I load the map because I knew more or less the location. Then I was playing with the coordinates and some rotation. And yeah, you just slice it down, and here was a beautiful Roman villa near the town of Grosseto in Italy. So as you can see, we also support third-party data, GPS, no GPS. GPS Insights will be available in October. We'll announce soon more news here. On the ecosystem, as Michael also explained, well, we didn't talk about Inspect today, but we have software that can be used for preparation also in terms of collecting any kind of data, visual data, photographs, and then while you are acquiring your data with your sensor and everything then is synchronized with the cloud, then you can also upload even photographs that you collected with the iPad during GPR data acquisition, or screenshots of what you have here, interpretation, everything, and then you can report, create an easy report from Inspect, or you can export, as Michael showed, directly from the app. But if you need a little bit more, as I was showing, then now we have Insights for data analysis. So now we think we have a more powerful, a more complete ecosystem to provide a digital workflow for you. So yeah, included in subscription, the workspace, and then as you probably know, GSGP, go with subscription, and GPR Insights would be optional within workspace. Just briefly on some of the technical features here. I don't want to extend too much, but we have an import-export. We have ready as-built and geomap, some third-party integration, as you saw, export as image and video. And the roadmap, we will be importing tags from our field interpretation, more third-party integration, more formats coming up soon. Multi-channel GPR, of course, this will be coming soon. In terms of efficiency, we already have auto radar signal processing in, auto slicing, one click, one main stage, 1 terabyte of storage. The roadmap, 3D drawing and collaboration. Although collaboration I showed you already, it's happening now. On the artificial intelligence and data analytics, we're already working on that, and we will have more news, interesting news to come soon on more filters, decoupled gridding, and then rich deck analysis, other things like horizon mapping, topography, vector correction. This will be in very soon. Just a recap on how you are gonna access GPR Insights through your workspace, log into your account, click on the GPR Insights logo, then you will be in. You will have your list of projects here. You can create a new project as I show in the videos. Then you can select from any GP or GS or other. If you are not from our ecosystem yet, you will have here your project details, amount of files, and if you have 2 frequencies, so you can do some selection here, put the name, and then click on create project, and then you go to the core, that is the visualization. As I explained, you would always have the frame here of workspace, so you can switch between apps without losing anything. You are now on GPR Insights. You can click on the GS, look at the list of measurements. You can go back to GPR Insights. You can go to inspect and go back and forth. So that's really flexible. So this improves your efficiency. We hope so. You can do fast data scrolling with C scans and B scans from the very beginning, and you can have all the needed functionalities like hyperbola fitting for dielectric constant estimation. And always everything happens from the main stage. You can export here the deliverables, import background information, as I said, and as I'm mentioning, everything from the main stage. Also the filters, you go to bandpass, you can see your spectral frequencies over there and choose your low and high cutoff for the bandpass. So you can do everything from the main stage. Just here a recap of features, seamless data import, not only us, but also others. And actually, if you export to SegWi, then you can import everything. Positioning lines, import imagery, as-builds, radar signal processing. We have the main filters. We will be adding more, of course, slicing and gridding, 2D, 3D visualization, exports, and data sharing. And yeah, with that, I just want to conclude saying that I think it's a great data analysis software solution, and it's an ever-evolving platform, as all our software is. So it will get better and better, not only for our systems, but also for third-party. And I think this could be your analysis platform, data analysis platform for all your subsurface work with GPR. All data is safely stored in our cloud. It's part of our NDT ecosystem with Workspace, as I showed. It will boost your productivity with these workflows. That's what we believe, and we work on every day to improve your workflows. And it's platform independent, so you would access insights from any device at any time with any operation system or web browser. So yeah, with this I conclude my presentation.